Hi everyone. Last time we talked about pre-algebra and elementary algebra and how they are key for tests like ACT and SAT. Today we are moving ahead into intermediate algebra and functions. In this lecture we will cover the following topics: polynomials and quadratic equations, factoring and the quadratic formula, functions, basics and transformations, and finally polynomial inequalities. Let us begin with the definitions of polynomials and quadratic equations. A polynomial equation has the terms like powers of x, like x, x square, x cube, etc. The biggest power of x is called the degree of the equation. And when we solve these equations, the answers are called the roots or zeros. These are the values of x that make the whole equation equal to 0. A quadratic equation is simply a polynomial equation of degree 2. It has a form like ax square plus bx plus c equal to 0. So, polynomial and quadratic equation, the relation is a quadratic equation is a polynomial of second order. Now we will talk about a factoring and a quadratic formula. Alright, let us factor a quadratic. Check out this equation which is given here: x square plus 5x plus 6 equal to 0. When you have any such problem, what you have to do is, first you find two numbers which are such that when they multiply they give a value of 6, and you add up, they become 5. So those numbers are 2 and 3. So the quadratic factors will look like x plus 2 times x plus 3, and your solutions will be x equal to minus 2 and x equal to minus 3. And that is how you can crack any quadratic equation by doing this factoring. And now the next comes the quadratic formula. When factoring does not work, we have got this powerful tool which tells us that x is equal to minus b plus or minus square root of b square minus 4ac whole thing divided by 2a. The part inside the square root b square minus 4ac is called the discriminant, and it is a very helpful quantity. It tells us that if discriminant is greater than 0, your equation will have two real roots. If it is exactly 0, it will have one real root, and if it is less than 0, there will be no real root and just imaginary ones. So the discriminant is like your secret code to know how many solutions a quadratic equation has. Let us use the quadratic formula on a real problem. Check out this equation: 2x square plus 3x minus 5. Here a is 2, b is equal to 3 and c is equal to minus 5. So now I will put values of these quantities in the quadratic formula. So x equal to minus 3 plus or minus square root of 3 square minus 4 times 2 times minus 5 divided by 2 times 2. So this becomes minus 3 plus or minus square root of 49 divided by 4. When I simplify, I get x equal to minus 3 plus 7 divided by 4 equal to 1, and the second answer is minus 3 minus 7 divided by whole thing as 4. So the answer comes as minus 2.5. So the roots of quadratic equation which we are solving are 1 and minus 2.5. Okay, so now it is your turn to try this one. Here is a quadratic equation 2x square minus 7x plus 3 equal to 0. What are the solutions of x? Think it through carefully and remember to use the quadratic formula if you need it. If you want, you can try doing by factoring also, but it may be a bit challenging. I will show you the correct answer at the end of the lecture, so stay tuned and check your work. All right, time to jump into something super important: functions and transformations. We will learn what functions really are and how we can shift, flip or stretch their graphs to create all kinds of cool shapes. Let us dive in and see how it all works. Okay, so here first thing that I would like to clarify is that don't mix up between quadratic equations and quadratic functions. Although they look similar, but they are actually different things. A quadratic equation is set equal to 0, like ax square plus bx plus c equal to 0, or x square plus 5x plus 6 equal to 0. So these are the examples of quadratic equation. But a quadratic function has a y, like y equal to ax square plus bx plus c. Here we use it to graph to see the shape of the parabola. You graph it, this function, to see the parabola's shape. With functions, we focus on whether it opens up or down, where the vertex is, what is the axis of symmetry of this parabola, and the y-intercept. So the example, say x square plus 5x plus 6, this is the example of a function, and this function represents a parabola. So remember, equations are for solving the function, while the functions are for graphing and understanding the shapes. Now let us dive into quadratic functions and their graphs. A quadratic function looks like y equal to ax square plus bx plus c. If you graph it, it is a smooth U-shaped curve called a parabola. We call it a parabola. It opens upward if a is positive, then it opens upward, and if a is negative, it opens downward, as shown in this figure. Vertex is the lowest or highest point. It is like the tip of the parabola, and you can find it at x equals to negative b over 2a. So vertex is minus b by 2a. So this point here is vertex, this point here is the vertex, and from this equation, if you can find the value of a and b, you can find where will be the position of this vertex as far as the x coordinate is concerned. So the vertex is the lowest or the highest point. It is like the tip of the parabola. This is the tip of the parabola, and you can find it by equaling b minus b by 2a. The axis of the symmetry is the vertical line that cuts the parabola right down the middle. So this is the axis of symmetry. Okay, in this case, the line equation will be minus b by 2a. And don't forget, the y-intercept is where the graph crosses the y axis. The y-intercept is at c, 0 and c at this point. This will be the y-intercept. So remember, quadratics don't just have the solutions, you don't just solve them, they have the shape, parabola shape. So you can plot it and you can see what kind of parabola you are dealing with. All right. Let us talk about transforming functions. Suppose you have got a function f(x). You can shift it, flip it, stretch it or shrink it, and every change creates a new graph change. Let us look into a vertical shift. If you add a number k outside the function like f(x) plus k, that is a vertical shift. If k is positive greater than 0, then you are shifting up, and if k is negative, that is less than 0, then you are shifting the new graph downwards. If you change inside the function x, inside the function instead of x, you make x minus h, then you are doing horizontal shift. If h is positive, you are shifting to the right hand side, and if it is negative, then you are shifting it to the left hand side. Now reflection. Negative f of x, if you just multiply minus 1 to f, then you are reflecting it over the x axis, while the f of negative x, function of negative x, is flipping it over the y axis. And finally, multiplying by a number a changes the shape of the graph. If a is greater than 1, you are stretching the graph, and if a is less than 1, it is between 0 and 1, then you are shrinking it. So remember, small changes to your equation makes big changes to your graph. All right, your turn again. Find out which of the following represents the vertical shift upward by 3 units of the function f(x) equal to x square. Remember, a vertical shift means adding or subtracting outside the function. Take a careful look at these choices and see if you can pick the right one. I will reveal the answer at the end, so keep watching and check your work. Here comes your next challenge. Which of the following represents a reflection across the x-axis for the function f(x) equal to square root of x? Remember, a reflection across the x-axis means flipping the graph upside down, which changes the sign in front of the entire function. Take a look at these choices and see if you can spot the right one. So again, I will show the answer at the end of the lecture. So keep stick around and check your work. Okay, so here is your next question. You have to find that the function gx equal to absolute value of x plus 4 is a horizontal shift of function f(x) equal to x by how many units and in which direction. Try it yourself. Okay, here comes one more for you. Which of the following shows a vertical stretch by a factor of 3 for the function f(x) equal to x cube? So just look into all these options and figure out which one is correct. One more. Which transformation changes f(x) equal to e to power x to gx equal to e to the power of x minus 2? You have to find again from these 4 choices. Try yourself and I will show you the answer at the end. Okay, so now we will move to polynomials inequalities. A polynomial inequality looks like px greater than 0 or px less than 0. A more practical example is something like x square minus 4 greater than 0. Now suppose you are asked to solve this inequality to find the values of x, then you have to follow these following 4 steps. The first step is to find the solution of the equation px equal to 0. Even though you have greater than or less than 0, but first thing we do is we find the solutions for a polynomial which is px equal to 0. After you have found the solution for this polynomial, you plot these values of this solution on a number line. Then you form these different intervals greater than the value of that solution and less than the value of that solution, and in between those two values, and you test. You put those values in this equation and see whether that inequality is true or not, and after that you find out the real solutions. You will understand more when I discuss this example. This inequality says x minus 2 multiplied by x plus 3 is greater than or equal to 0. We are asked to find the values of x which satisfies this inequality. So, first thing that I will do is I will just put it equal to 0. X minus 2, x plus 3 equal to 0. And it is very easy to find that solution for this equation will be x equal to minus 3 and x equal to plus 2. Now, I will test different intervals. First thing, I will see whether this inequality holds when I go to the left of minus 3. And if you put value of minus 3 for x here, you will see it is true. That overall number after you put minus 3 will be greater than 0. Now, I will test between minus 3 and 2, let us say number say 1. Put value of x equal to 1 again in the inequality, and you will find that it is false. It is not, inequality is not holding. Then let us test for value on the right of 2 on the number line, say 3. And if you put the value of 3 again in this inequality, you find that is true, that inequality is value of inequality is greater than 0. So, your solution will be x is less than minus 2 or x is greater than 2, because in this two ranges this inequality holds true. So, that is the way how you have to solve an equation which is given to you. So, now here is another question for you to try on your own. The inequality x square plus 2x plus 1 is less than or equal to 0. How many real solutions it has? So, you have the 4 options, find out one, and then I will show you the right answer after this end of this lecture. Another one for you, it says solve the inequality which is x times x minus 5 greater than or equal to 0, and you have been asked to solve. You have been asked to find the solution set out of these 4 options. Try yourself. I hope this quick review of polynomials, quadratic equations, functions, and inequalities gave you a solid boost for your math preparation. Remember to practice a few problems every day. It makes a lot of difference. Thanks for watching, and now let us check out the correct answers to the questions you tried today.